In this next video, we're going to talk about a concept called ionization. Now, as we look at ionization, you're going to wonder, is there any difference between ionization and what we learned in the beginning of this section called dissociation? The answer is the end result is no. There is no difference. But we use a different term because of the type of chemical we're talking about. So ionization, we are forming ions. Okay? So that's the key point. Now, when does ionization occur? Ionization occurs when we have polar covalent molecules, water, carbon dioxide, technically HCl, things like that. It's when those polar covalent compounds actually form ions. I think, wait a second. Okay, again, covalent's not ionic. How can they form ions? Well, again, it's the concept of having those elements gain and lose electrons. It's not as common, but it is possible. And again, the distinction is dissociation is the term for when ionic compounds form their ions. So they dissociate, they separate what's already there. Ionization is the actual process of changing those atoms into ions. So let me give you two examples. Hydrochloric acid, HCl, polar covalent compound. When we mix it with water, HCl, because it's very, very polar, will dissociate into the hydrogen ion and the chlorine ion. Now, again, not every polar covalent compound does this. Some do it more than others, but again, they're just the concept. Another way to write this would be HCl, again, which is very polar, plus water. We write H3O plus. Now, H3O plus is what we call a hydronium ion, plus chlorine. So if you notice here in this first one, it's H plus, and the bottom one's H3O. Well, really, we still have water being produced on the right-hand side. This is like a spectator. So, and we'll learn about acids, bases more next chapter. So when it dissociates, we can say H pluses and Cl's, but also what happens is those H pluses merge with waters to get H3O pluses. And you'll see that we kind of go back and forth between do we write H plus or do we write H3O plus? Now, the thing we want you to remember is these two terms right here. What's a strong electrolyte versus what's a weak electrolyte? Strong electrolyte, weak electrolyte. We talk about chemicals that can ionize, can conduct electricity, as well as some other properties and characteristics. The thing I want you to remember as we talk about it in this section is what it means in terms of a chemical being able to ionize. If we see the term strong electrolyte, so HCl is a strong electrolyte, that means all of the potential ions in that chemical will dissociate. Will ionize. A weak electrolyte only partially ionizes, and what that means is less than 100% will actually change. And that's all we're trying to figure out from this. You don't have to necessarily know yet what's strong and what's weak, but you do need to know if it's strong, what it means, or if it's weak, what it means. Let me elaborate a little bit more on the strong and weak electrolytes. So, again, strong electrolyte completely dissociates, dissolves, ionizes. Use those three words interchangeably, although we probably shouldn't, but we understand what that means. Weak electrolyte only partially will dissociate, dissolve, or ionize. So here's the example. Strong electrolyte, HCl. If we have a certain amount of HCl, 100% of those HCl's will break apart into their two ions. We can either write it as H plus Cl, and again, we know kind of in parentheses here, we've still got waters because back here in parentheses, we still have waters. Or we can just completely ignore the plus waters on both sides and just say HCl dissociates into H3O plus and chlorine ions. Any chemical that's a strong electrolyte, that's what we do. Now, to give you an example of a weak electrolyte, that would be acetic acid, HC2H3O2 or CH3COOH, both weak electrolytes. So in this case, a weak electrolyte, all we're saying is it's less than 100%. Well, how much less? It depends upon the chemical. But if we have a certain amount of acetic acid, some will break apart, right? The hydrogen breaks apart from the rest of the ion, the acetate ion. But we also are going to have a significant amount of acetic acid that never did change. For example, let's just say I had 10 of these. What that might mean is 3 of them break apart, some of them don't. Maybe we've got 1 mole of them. Maybe 0.2 moles break apart into those two pieces, and zero point 0.8 moles do not break apart. That's significant because when we do deal with reactions involving weak electrolytes, we're not going to make as much chemical as we thought because the majority of that chemical never changed. Okay? Again, we don't have to know yet which chemicals are strong and weak electrolytes. We just need to know what that means. So that concept, strong electrolyte and weak electrolyte, you need to kind of hold on to because we will use that next chapter when we talk about acid-base reactions, and then eventually kind of an advanced concept that we will just barely touch on this year, but a lot in AP Chem, is the concept of equilibrium. Okay? So that's the end of section 1. Really the only thing we have left is to talk about some colligative properties in the next section.